Hi, my name is Patrick Cox. This program will cover design methods from a real project for eliminating man-made pollution flowing to our rivers, lakes, and streams by means of stormwater runoff. To comprehend the problem, we must first understand some basic concepts. When the amount of rain falling exceeds the land's ability to absorb it, the result is stormwater runoff. The volume of runoff at which it flows varies depending on the type of land surface where it falls. A medium storm event over a wooded or meadow land area might produce little or no runoff, while the same rainfall event falling on an impervious parking lot or building can produce a substantial amount of flow, which can easily flood downstream properties.
Some of the traditional ways to manage stormwater was to really focus on volume and the amount of water that was running off of a property. And that was the first major concern because it was causing flooding issues. It was causing our rivers and streams to overflow its banks or to be eroded. But to look at stormwater in a more holistic way, we need to also look at the water quality, not just the water quantity. And a lot of the stormwater practices that we're advocating for today and that we're putting in on the ground addresses both of those needs. It slows the water down and it cleans the water up.
Stormwater runoff leaving existing built areas is unhealthy for people and bad for the environment. Runoff can carry all kinds of pollution: chemicals, metals, bacteria, viruses, organic compounds, and other pollutants directly into our rivers, lakes, and streams. And the higher rate of stormwater runoff can cause severe erosion and flooding. The effect of these pollutants on our waterways are tremendous. A survey by the U.S. Environmental Protection Agency found that 40% of rivers and 45% of lakes in the United States are considered too polluted for fishing, swimming, aquatic life, and drinking water. The source of the major pollutants in our waterways can be broken up into 5 categories: sediment, chemicals, oxygen-depleting nutrients, metals, and biological pollution. Pollution can reduce or totally eliminate oxygen in the water, killing fish, reduce photosynthesis of aquatic plants, and increase the temperature of water by absorbing more sunlight. These changes can have devastating effects on aquatic ecosystems and the quality of our drinking water. According to a 1992 Environmental Protection Agency report, stormwater runoff is the leading cause of surface water pollution. Did you know that 1.2 trillion gallons of raw sewage, stormwater, industrial waste, and 73 different kinds of pesticides are dumped into U.S. waters annually?
Drinking water is a major concern for everybody. Whether we wake up in the morning and we brush our teeth, or we turn on the faucet, or we wash our clothes, typically during those times we're thinking about the million other things that are happening throughout that day, or the vacation that we have planned, or the challenges that we have coming up at work. We're not always thinking about where that water is coming from. But it's coming from our environment, it's coming from nature, it's coming from that rain that falls out of the sky onto the ground, that gets into our rivers and streams. That is the water that we drink, so protecting that is very important.
In America, 1 in 6 children is exposed to mercury levels high enough to put them at risk for learning disabilities, motor skill impairment, and short-term memory loss. EPA has divided causes of water pollution into 2 categories: point source and non-point source pollution. The first, point source pollution, are direct discharges coming from factories and wastewater treatment plants. These are fairly easy to find because you would have a fish kill, an algae bloom, or change in water color, and it makes it easy to trace back upstream to find the pipe where it came from. EPA has been cleaning up this type of point source pollution for about 40 years, and industry had to pay fines in the millions of dollars. I remember as a child in the 60s how rivers used to catch on fire from all the pollution being discharged into those rivers. The EPA's second cause of pollution is non-point source, which is stormwater runoff. And this is much harder to pinpoint and do something about. All new land development requires stormwater retention ponds that are designed to remove pollution and attenuate or slow down stormwater before it leaves the proposed project site. These new retention ponds work very well. The problem is all existing built areas over 30 years old have no stormwater treatment systems whatsoever. All the runoff from existing parking lots, buildings, farms, and so on carry pollution directly to our waterways. It's easy to understand why we have a pollution problem. All you need to do is picture rainfall runoff leaving existing built areas. Suspended in this runoff are pollutants such as herbicides, pesticides, and fertilizers from lawns, oil and grease from paved areas, and chemicals from industrial sites. All these pollutants are carried directly to local streams, lakes, and rivers by existing underground pipes or overland flow.
I'm Brady Russell with Clean Water Action, and Clean Water is very focused this year on the new PAG 13 stormwater permit. That's just cities in Pennsylvania that are MS4s, which means municipal separate stormwater sewer systems. They have a permit with the state under the Federal Clean Water Act that regulates how they manage the rain that falls in their communities. So, you know, rain falls on streets, it flows into stormwater inlets, it maybe gets a little treatment, and then it's dumped into our rivers and streams. And so far, I mean, the way Pennsylvania has approached this is the rules basically say just, you know, get that water into the stormwater system and out to the streams as quickly as you can, and you've done your work. But the problem is, you know, it picks up all this pollution, and the water itself is kind of a problem too. You know, one person once said to me that the biggest pollutant in Pennsylvania's waterways is actually water, because so much water goes into the waterways so fast, so much more than the natural system would send in that quickly, that the water itself tears up the waterways. So we need to slow it down and clean it up.
Acknowledging these stormwater pollution problems, the U.S. Environmental Protection Agency is demanding local governments to develop solutions and find innovative ways to mimic the environmental functions that existed before we disturbed the natural landscape with buildings, farmlands, parking lots, and roads. The solution lies in a comprehensive stormwater management plan, which offers tremendous rewards to local economies, the environment, and the quality of our life.
Okay, my name is Joanne Donahue. We are here at the Schuylkill Center for Environmental Education. I'm the manager of land restoration here at the center. And we're talking about stormwater and the things that we do to help to mitigate the problem of stormwater. One thing that people don't realize is that stormwater is best dealt with prevention measures. When stormwater is allowed to build up velocity and volume, that's when it does its damage. It scours stream banks, it causes erosion, it takes sediment from the land, takes soil from the land and carries it into the stream, where it destroys aquatic habitats and causes a bunch of problems further downstream as well. So the more we can do to treat stormwater on site, the better off we are. When you're talking about a watershed scale, the best place to handle stormwater is at the headwaters and all along the watershed as you go downstream. The more you can do on a small scale, instead of letting stormwater become this huge issue with huge volumes where it's causing millions of dollars worth of damage on a municipal level, it's best dealt with on, you could even think about on a homeowner level. When homeowners are educated about ways they can help their communities and the health of their local environment by doing small measures, small practices on a home scale, most people are willing to do that. Things like installing a rain garden, using native plants that are made to handle those conditions, periodically inundated after a large rain event. And that area can still dry out after some time. These plants are accustomed to these conditions. Also things like putting rain barrels under your gutters to prevent that water from leaving your site, from going into this underground system of pipes and culverts that eventually ends up in our streams without being treated. Why not use that water on site to water your vegetable gardens or do other things around the yard? This is the best way to treat stormwater. Keep it on site so it doesn't become the problem that it is, that it causes when it causes thousands of dollars worth of damage.
What you are about to see is a design project that we did for the Quakertown borough located in Bucks County, just north of Philadelphia. The following program covers a stormwater management plan which involves the design of stormwater management systems that will remove pollution from rainfall runoff as well as slowing down runoff to reduce flooding downstream. Now, flooding has been a problem for a long time in the Quakertown area. This example design will help guide communities in developing their own design plan to help meet their DEP LMS4 requirements. The best solution is a natural wetland type of system, and that isn't hard to understand. Just picture rainfall over an undisturbed forested area. Pristine woodlands, rain falling through the trees, hitting the ground and flowing through ground cover vegetation before accumulating in a stream, river, or lake. Even though this water hasn't been processed through a water treatment plant, you innately know it's clean enough to drink. It was purified by natural biological processes before it flowed to that stream. Both DEP and EPA recommends natural filtration methods for treating pollution and stormwater runoff. All the treatment systems we used in our Quakertown borough design use wetland and upland vegetation to remove pollution from stormwater runoff. These plants grow naturally along the shoreline of all waterways if given a chance. We design riparian buffers and littoral zones to accommodate and promote biological processes. The design process started with public participation meetings, but before the first meeting, we had to do some preparation design work. This design process started with a meeting with the Department of Environmental Protection, both in the regional office and the local conservation district. They informed us of problems in the area and pointed to one specific storm system that wasn't functioning properly. We then contacted the Quakertown Borough Manager and Public Works Director and discussed some of these issues with them, and they arranged our first public participation meeting. This first public participation meeting was eye-opening, and they told us where the real problems were. These local people who have seen stormwater problems year after year knew exactly where they were located. So with the local people and a few field visits, we had a much better understanding of where we should focus our attention. We then put on our design hats and developed a preliminary sketch plan which covered all of the problem areas that we discussed with the local township. After that plan was complete, we held another public participation meeting, and after receiving solid feedback from everyone, we had a good understanding of what the final design should be. The plan was to improve the upstream tributaries to Licking Run Creek, which runs through the heart of the Quakertown borough. Now, this plan consists of stormwater management systems in key locations. The first step in this process was to determine where land or undeveloped open space were along the tributaries and find out who owns these properties. The property along waterway tributaries are where the outfall points are for all existing stormwater systems. In other words, this is where the drainage pipes from the existing built community comes in contact with the waterway that we want to improve. This location is where the storm pipes are draining into the waterway and is the most efficient place to construct stormwater runoff treatment ponds. And these drainage pipes are where the most concentrated pollution is flowing into our rivers, lakes, and streams. All waterways have easements over them, protecting them from being developed any farther. These easements must be defined and studied to determine what size treatment pond we may construct there. The larger the easement, the bigger, more natural pond we can install. The smaller the easement, the more likely we have to construct a small structural type of system. The local county clerk's office is where you can obtain the waterway easements, size, and also who owns the land. In some cases, it's government owned, and in some, privately owned. Of course, government-owned easements are the easiest to gain permission to do improvements on. But many private property owners are willing to help improve the environment, mainly because they cannot make any modifications within these easements, and if you can make it better, they will go along with it. Most waterways have protection easements over them, but they do vary in size tremendously. For a long portion of the stream, you may have a 20-foot wide easement covering the waterway, and just downstream from that, you could have a 150-foot wide easement covering that same waterway. This is common in all municipalities. The reason for these discrepancies is simple. I only have to remember 35 years ago when we subdivided land, the local government and DEP only required a 20-foot wide easement over existing streams. As the years went by, the easement width increased to 30 feet, then to 50 feet, then to 150 feet. The reason they increased the width so much was to include more riparian upland buffer area to help protect the wetlands from runoff flowing to it. So depending on when the property was subdivided dictates the size of the existing easements over any waterways flowing through that property. In today's world, developers are required to provide open space, and it is common to dedicate up to 50% of the proposed development for open green space. So most developers design the open space areas over existing waterways running through their property, mainly because the waterway protection easements and open space can utilize the same area of that property. This can substantially increase the size of new stormwater management systems within these larger tracts of land. Of course, this is a fairly recent requirement, and all older properties have no open space requirements with very small waterway protection easements. The goal is to construct stormwater systems in all available land along waterways. The design of natural biological ponds and structural ponds are both needed. When a larger tract of land is available, such as an open space easement, a natural pond should be designed and constructed. When the area is very limited, for example, a 20-foot wide easement over a stream, a structural system such as a sump inlet with a skimmer device could be constructed at that location. These structural and natural systems can work together. The goal is to remove as much pollution from runoff as possible. The natural wetland system is several times more effective at removing pollution than a concrete structural system. But if you only have a small tract of land available, then you must install a structural system. Any pollution removal is better than no pollution removal. Ownership of the property is a determining factor because you must have permission to construct these systems from the landowners. Some conservation easements have been dedicated to local municipalities. Some are owned or controlled by other government agencies such as state parks and school properties, and some are privately owned. The owners of private property may want to help, especially if they see this as an improvement and becomes an asset to their own property. You know, a beautiful wet bottom pond can improve the property value, and this should be pointed out to that property owner. The best strategy is to do a preliminary design plan covering as much property as possible and then approach the owners and hope for the best. You will most likely have a percentage of the property owners that will not participate now, but may become interested later after they see the improvements on other properties. Some property owners may just allow a small structural water quality outlet structure, and that is better than nothing. Of course, all the areas controlled by the municipality where permission is not required should be used to the maximum benefit. And constructing a large wet bottom stormwater pond surrounded by beautiful natural vegetation is an improvement to any community. Now, the next step is the preliminary plan with a set of preliminary stormwater calculations. These calculations would show how much pollution is being removed from stormwater runoff and how these stormwater ponds reduce flooding of downstream properties. Almost all municipalities have issues with flooding, and these systems will greatly reduce the rate of discharge and lower flood stages downstream. For example, the Quakertown Borough preliminary stormwater routing calculations demonstrated the abilities of the proposed stormwater improvements to attenuate or slow down the stormwater runoff in the proposed waterway and floodplain restoration areas. When you do calculations, you compare the total rate of discharge for existing conditions and what flows out after you did your improvements. By combining all of the individual stormwater pond outfall points together, we determine how much we would slow the stormwater down. The existing peak flow is 752 cubic feet per second for a large storm event. After all the improvements are constructed, the total peak flow will be reduced to 178 cubic feet per second. That's down from 750 cubic feet per second to 178. And that is a 76% reduction of stormwater runoff that used to cause flooding of downstream properties. Presently, for small storm events, the existing waterways are receiving stormwater runoff from built areas in short bursts of time, a few hours. Now, this is caused by the rapid storm runoff flowing from existing impervious pavement and building areas. After a couple of days, the stream dries up. The proposed waterway improvements will provide storage areas with natural vegetation to slow down and to extend the stream base flow over a much longer period of time. This will reduce the tendency for the Licking Run Creek to be flooded after a storm event and then be dry the following week. These waterways will have a steady base flow of clean water over a much longer period of time. The majority of stormwater ponds we design are natural systems. In the riparian areas, we use a variety of plants including switchgrasses to help remove nitrates from stormwater runoff. In the littoral zone planting area, we specify emergent plants such as bulrushes, arrowheads, pickerel reeds. For the floating plants, we specify lotus and water lilies, and for submergent plants, we specify bladderworts, pondweed, and wild celery. All of these plants do an excellent job of removing nitrates, phosphates, and suspended solids from stormwater runoff. Another benefit of waterway restoration is the reduction of greenhouse gases, which consist mostly of carbon dioxide emissions from burning fossil fuels. When waterway corridors are restored through existing built communities, they provide an abundance of vegetation along the riparian corridor, both in the littoral zones of the waterway and the upland buffer areas between the waterway and built areas. This lush vegetation is great at sequestering CO2 from the air that we breathe. Okay, the large corrugated pipe that you see behind me is conveying 23 acres of untreated stormwater runoff to Licking Run Creek. This untreated stormwater runoff is flowing off existing built areas and conveys pollution such as oil and grease from roadways, pesticides, herbicides, and fertilizers from yards and gardens, and also chemicals from the existing industrial park that lies north of Quakertown here. The industrial park can have an array of different chemicals that they may spill or put on their property that can be picked up by stormwater runoff and conveyed to Licking Run Creek through this very large stormwater pipe that you see behind me here. What we're proposing is to take this pipe offline and put a large stormwater wet bottom retention pond in the middle of the park here that will treat this stormwater runoff before it flows to Licking Run Creek. This wet bottom biological pond will have littoral zones all the way around the shoreline that will provide wildlife habitat and areas of wetland plantings so that the plantings can be used to absorb the pollution that flows from this 23 acres north of Licking Run Creek here.
I'm Bob Adams from Wissahickon Valley Watershed Association. We're a long-time watershed group. We got started back in the 50s, so we've got over 50 years of working on the creek. One of the first things we did was to try to establish a good stream buffer along the creek, and that took us decades to do. Piece by piece, we assembled parcels of land like this one. And as part of that effort, we decided to install a walking trail through the stream buffer so that people could get out and enjoy the creek and understand what we're trying to protect. If you don't love something, you won't protect it. And we want the trail to introduce people to this beautiful creek and help them to love it. So at this point, we've managed to put a trail in for almost 13 miles down the creek. And the buffer is pretty good. We've either protected or caused to be protected all the land along the creek with a few minor exceptions. What we're looking at over here is our first major in-stream effort with funding from a pollution fine. We took out an old farmer's bridge that was right about at the end of that rock structure there coming across. The water had eroded around the end of the bridge so that the stream bank was actually about 10 feet back from the end of the bridge. So it was no longer usable. It was, a public hazard, and it was causing a lot of sediment to go down the creek. So we took that bridge out and then installed the structure that you can see. It's called a cross vein. And what it does is pushes the water flow into the middle of the creek so it doesn't, it stops eroding the stream banks. And this, of course, reduces sediment in the creek.
What we have here are 3 existing ditches that run through the middle of the Richland Shopping Center just north of Quakertown here. These existing ditches collect about 61 acres of stormwater runoff from a tributary just north of here. This tributary consists of a lot of existing impervious area. You have industrial areas, you have businesses and shopping centers, and not to mention also State Road 309, which all the discharge from these areas flows through these 3 ditches. Now, each one of these ditches are connected with a large culvert, and there's a road going over there to the shopping centers. At the location of these 3 culverts, we propose to install a weir system that will slow down the stormwater discharge to help these existing ditches become biological retention ponds. Presently, these ditches are very good at conveying stormwater runoff, and because they are full of wetland vegetation, they do some stormwater treatment. We propose to enhance this stormwater treatment by installing weirs at each one of the culverts so the water will be detained within these ditches for a short period of time. These weirs will be made of stone gabion baskets which allow water to flow through them, and when water flows through a stone gabion basket, it actually provides water quality treatment with the biological processes or bacteria that lives in between the stone. By slowing the water down, you give the wetland vegetation a much better opportunity to treat the stormwater. You allow the wetland vegetation to absorb more pollution being conveyed by these 3 ditches. What we have here is an existing ditch that flows behind the Richland Shopping Center, and it's basically just a conveyance system flowing through an existing wetland. And this system has a control structure, which you can see behind me, but this control structure has a very large 54-inch orifice that doesn't really slow the water down. What we propose to do is place a stone weir in front of that large orifice to slow down the stormwater discharge. We also propose to enlarge this area that I'm standing on into a wet bottom retention pond with wetland plantings in the littoral zone. It provides more storage and treatment of stormwater runoff. Okay, what you have behind me here is a very large ditch flowing to an existing ditch that is a tributary to the Licking Run Creek. Now this ditch is connected to the parking lot behind me, which is a humongous parking lot. Now what we propose to do is place a small sediment forebay with a stone overflow weir, so the water that comes off that huge parking lot and building area has a chance to be detained for a short time before it overflows that weir. What this does is provide thermal treatment of the water. It allows the water to cool down some on hot summer days when that water comes off that parking lot very hot. Now that water can cool down some. It also provides sediment control. So before it overflows the weir, the water will settle out some, and all the fines and pollution from that existing parking lot will be treated in that sediment forebay before it discharges to our proposed wetlands. Now the maintenance of this system is very simple. Just 2 times a year or after every huge storm event, it should be cleaned out, all the sediments should be removed. We are also proposing a series of bioswales that will run in between Cemetery Road and the cemetery itself. The bioswales will be going along with the slope of the road, so it'll be cascading down with weirs located at about every 1 foot of drop of roadway. What happens is water that is flowing to the upper bioswale will overflow the weir and discharge to the next to the lower bioswale, and then that water will overflow into the next to the lower bioswale. What happens is you get a lot of treatment of stormwater runoff because it's flowing through so many bioswales before it reaches the outfall point. So this is a very effective way of providing water quality treatment for surface stormwater runoff. Hi, this is the Quakertown Sports Complex, and they have 2 existing retention ponds, dry bottom retention ponds, adjacent to their 2 big soccer fields here. So these 2 retention ponds are also adjacent to existing wetlands, and what we propose to do is to expand those wetlands and incorporate these retention ponds as wet bottom ponds, biological systems, and connected with the wetlands. And that way we provide a lot more treatment area for stormwater runoff. Presently there are about 70 acres of stormwater runoff flowing to these 2 retention ponds. Hi, this is the existing wetland located just north of Golden Gate Drive. The wetland is located in a conservation area, and what we propose to do is restore this waterway to a wet bottom biological system. What this entails is digging out the center portion of this and creating an open waterway, and then we'll have very flat littoral zones on all sides that will provide habitat for wetland plantings and wildlife. There will also be a weir that will be constructed in front of these culverts behind me here, and this weir will be about 2 feet high, and it will be made of stone or gabion baskets. Now what this does, it provides water quality treatment by slowing the water down and allowing that water to stay in the wetlands longer. The longer that water stays in the wetlands, the more the biological plants can absorb the pollution. Also, it provides flood control. By attenuating the water or slowing it down, you prevent flooding downstream. The good thing about slowing the water down too is you give a chance for the sediment to settle out in the wetlands themselves, and the biological processes can happen more efficiently. This is an existing wetlands located on the west side of 309 and just north of the Kmart Shopping Center. A lot of polluted runoff comes from State Road 309 and also from the Kmart Shopping Center, as well as other properties upstream of this. The total tributary area to this wetland is 182 acres. What we propose to do is to expand this wetland into a wet bottom retention pond with littoral zones and detain the water in there longer so the wetland vegetation can eat up the pollution coming from this large tributary area. Not only will the biological processes happen in the littoral zones, but you also have anaerobic bacteria that will eat up the pollution that is settled to the bottom in the deep water areas. Another benefit of this is to provide flood control for properties downstream. This wetland will attenuate or slow down the stormwater runoff flowing downstream and help lessen the flooding problems they have there. Of course, like all of the other systems we're doing here, we're installing a stone weir, either made of stone or gabion baskets. This weir will help to slow the water down so the biological processes of the wetland vegetation can take place. Also help to settle out these sediments in the stormwater runoff.
Hi, my name is Sean Duffy. I'm Director of Land and Facilities here at the Schuylkill Center for Environmental Education. What we have here behind me are two water collecting cisterns for collecting rainwater. They collect about 2,500 square feet of our roof, and in a 1-inch rainfall, we'll collect about 1,500 gallons of water out of that. We installed our cisterns because we do not have city water here at the Schuylkill Center, and we needed a way to fill up our fire pond during dry times. So when we have rain events, we store the water in the water tanks, and as the pond starts to lower, we send the water out into the pond.
One of the projects that Cedar Run staff and volunteers are working on is we are currently creating a 1,000 square foot rain garden on the property of a local elementary school, Taunton Forge Elementary School, right here in Medford, New Jersey. One of the reasons that we are doing that is because we are creating a buffer zone between school, the parking lot, runoff, and a creek that leads to the Rancocas Creek, which then leads to the Delaware River. That buffer zone that we are creating in the form of a rain garden is also going to serve as habitat to many of our native pollinators. Our native pollinators are in peril. And this rain garden will not only serve as a habitat for our native pollinators, who pollinate up to 60% of the food that we humans eat, but it will also serve as an outdoor classroom. This entire project of 1,000 square foot rain garden is costing us less than $1,200 to put in. And it is being created mostly by volunteer work effort. These are some simple things that each and every one of us can do or can learn more about, encouraged others to do, that can help our migratory species, our native pollinators, and our natural waterways by creating waterways and buffer zones.
And there's a larger theme to our program that we're putting out there that we think is important for communities to think about. We've launched this website, swimmable.us. The idea is to get our country one in which all of our streams are swimmable. You know, the Clean Water Act says that the waters of the United States should be fishable and swimmable again. And it's that idea of swimmability which really grabbed us, because if you as a human being can't feel safe getting in a river or stream, well, that just shows you that there's a real problem in an environment. There's nothing like swimming to capture the idea that you know, water is healthy and water isn't a danger to public health. So we want to see the waters around here be swimmable again. And so a part of our swimmable program is helping communities and, you know, honestly pushing communities and organizing communities to get more serious about the kind of waste that they're sending to our waterways from the rain that falls in the community. So the first step in our plan is we're using a tool that it's a free tool that the Center for Watershed Protection put out, and it's an ordinance evaluation worksheet, and it's just like 30 or 40 questions about the local code of a town, and you know, things like how many parking spaces do you require for your estimated number of customers? How big are those parking spaces? Do you allow for vegetation in parts of roadways that can have vegetation? Like, for example, cul-de-sacs. You say it's allowable to put a garden in the middle of the circle of a cul-de-sac. And there's some more advanced stuff in there too, like things about street length. Do you encourage shorter street length and street width, and do you have a buffers program, that sort of stuff. So things that allow a community to have more of the rain that falls on the site get absorbed by earth and dirt and trees and shrubs, and less of it just rushed out to the stormwater system as quickly as possible. So we're going through communities right now, mostly in Chester County, and just doing the worksheet on their code. And it's interesting because folks often say that it's the communities in Southeast PA that are the greenest because they have the most flooding problems. But so far, and we've probably evaluated about 15 towns at this point. The highest score we've seen, I think, is 65 on a scale of 100. And the Center for Watershed Protection says if you're in your 60s, you have serious problems and really need to reform. But honestly, lots of towns are scoring more like in the 50s or even the 40s. So there's some pretty bad scores out there, and there's some real low-hanging fruit that communities aren't looking at. So just allowing people to make their driveways porous, or to have two-track driveways where there's some vegetation down the middle, so it isn't all concrete. Setting new rules where our streets won't be quite as wide, and we'll have more porous pavement and lower trafficked pavement areas. We'll start requiring our parking lots to be partially vegetated. Things like that. Can you get behind that? And we know folks will, because we know people care about these things. And so, if elected leaders start to hear about that, we'll move forward.
When waterway corridors are restored through existing built communities, they provide an abundance of vegetation along the riparian corridor, both in the littoral zones of the waterway and the upland buffer areas between the waterway and built areas. This lush vegetation is great at sequestering CO2 from the air that we breathe. Also, a good waterway restoration plan will include a jogging and bike trail to connect neighborhoods outside of the city with business districts downtown. The more people use these trails, the less they use their cars, and the less CO2 is emitted to the atmosphere. Sidewalks in and outside of the city connect to this trail to provide an alternative to driving our cars every place we go. This is downtown Quakertown. It's a great walkable community, and the only problem we have here is it's not really connected to the outer suburbs with sidewalks. These connections can create a community where it did not exist before. Neighbors can actually meet each other on these trails. Both young people and seniors have a way of traveling that doesn't depend on relatives or the automobile. The great thing about a walkable community is a family can get up Saturday morning, hop on their bicycles, and ride all the way from their suburban home to downtown along the bike path that we installed along the waterway restoration that we did. If you have ever taken a bike, walking, or jogging path from your home in the suburbs to downtown, you know what a great feeling that is. You can hop on your bike, you can ride all the way downtown, lock up your bike, enjoy the day downtown, and then hop on your bike and ride back home. Not only did you have a nice day out, you got some fresh air and some exercise. As the great planner Jane Jacobs said about walkable communities, eyes on the street, a reference to what would later be known as natural surveillance. People looking out for one another instead of a life of isolation some of us have created in our suburban life. Also a good jogging and bike trail along the waterway is an opportunity to provide education about wildlife habitat. Educational signs will be installed at key locations to help with knowledge about local wildlife and biology. Recreational trails offer many benefits to your community. They promote physical fitness, encourage family outings, and are a source of pride for the community. These trails will encourage more people to take part in outdoor activities and enjoy the natural wonders provided by the restoration of your waterways. When you connect the suburbs to local downtown business districts, you actually create a community. People in the suburbs can get to know the people in the city and vice versa. I'm originally from Louisville, Kentucky, and I lived downtown most of my life until I got married and moved out to the suburbs. Well, I noticed a big difference because when I lived downtown, we could drive someplace if we wanted to, but we could also walk. It was not uncommon for us to walk to a movie, to go shopping, to visit friends, or go to a park. Walking was a normal way of life there. And if your car broke down in the city, you did not have a problem in getting around because you could walk to places to go shopping or take a bus to go to work. Now, after moving out to the suburbs, I noticed you were somewhat isolated. So my wife and I decided, let's walk down to the local restaurant and see how that goes. Well, what you notice is sidewalks are very intermittent out in the suburbs. It is very dangerous to walk along these fast-moving highways to go any place because the cars are going by at 55, 60 miles an hour, and you do not have sidewalks in all locations, so you have to walk next to the road in some places. We only tried this one time, and after that, our car became attached to our hip. We drove every place we went. Now that's a real shame because you lose a sense of community. You do not know your neighbors, you do not know people who own local businesses. All you do is just hop in your car, go through the local drive-through, get some food, and come home. It's very isolating in its own way. Now, downtown communities don't have this problem because you can walk pretty much any place you want to, or drive there if you like to. You have the options. With our design of a walkable community connecting the suburbs to the downtown business district, we actually can gain the community back for Quakertown. The people in the suburbs will get to know the people in the downtown business districts. You know, the public can participate by doing simple things themselves. They can conserve water whenever they can. Encourage natural buffers to grow between built areas and waterways on their property. And they should not remove buffers that already exist. They can reduce, reuse, and recycle as much as possible. Use fewer and less harsh cleaners and chemicals in your home. Don't use chemicals on your lawn and garden. Be more energy efficient and use renewable sources of energy such as wind, solar, hydro, geothermal, and biofuels whenever you can. Buy local food and other products instead of those that have been transported over long distances. You can walk to local places instead of driving, and use public transportation whenever you can instead of using your own personal vehicle.
My name is Jen Ranley. I'm the Education Director at the Schuylkill Center for Environmental Education in Philadelphia. And the Schuylkill Center does environmental education in a variety of ways through direct outreach into communities, working with students from Philadelphia and all of the surrounding communities, working with homeowners, and also supporting teachers in their efforts to bring environmental education into the classrooms as well. So our 350 acres serves as an opportunity to be an outdoor classroom for many schools, the thousands of students that come to visit us each year. But part of what we do is also training teachers through professional development to deliver environmental education in the classrooms and implement some of the green practices like we do here at the Schuylkill Center in their own schoolyards and in their own communities, which is incredibly satisfying for us to see the efforts that get spread throughout the city of Philadelphia and beyond.
What we're looking at here, we're at the Schuylkill Center for Environmental Education, and they do a lot of work with stormwater issues, and they try and not only teach about stormwater, but they also try and practice what they teach. So they install a lot of practices on their facilities to manage stormwater. Two of those practices right behind me can be seen. We have a rain garden, which is right here, which collects the water from the roof or from the pavement that we're standing on and allows the water to flow into there So it can be absorbed by the plants that we see behind us, or it can infiltrate back into the ground or evaporate through the atmosphere. Rain gardens are designed to get rid of the water that is stored in them in 72 hours. That prevents any concerns with mosquitoes. But when you look at it, it's not a very complicated type of system here, but it does a great job at addressing stormwater. And up above here, it might be a little bit harder to see. On the roof here, you'll see that it's not your typical asphalt roof or metal or any other type of hard surface. It's actually vegetated. It's a green roof, and that serves the same purpose that the rain garden does, which is to allow the stormwater to flow on that roof, and rather than run off, those plants on that roof will absorb that water, will allow it to collect like a big sponge on there, and then release slowly into the atmosphere or be taken up, like I said, by the plants. So there are two very good examples of things that we can do when it comes to controlling stormwater on our properties.
Communities in Pennsylvania are rewriting their permits for stormwater this year, and this may be the last time they do it for it definitely won't be sooner than 5 years. It might be 6, 7, even 8 years until they do it again. So communities are going to be talking about stormwater over the next 12 to 18 months, and this is our chance to get in there and say to those communities, look, you need to make a plan to become more low-impact development friendly, to make your town more like a sponge, absorb more rainwater on site, send less rainwater directly into the streams with less pollution in it, and then we'll all be better off. Our waterways will all be cleaner, and more of our streams will be that much closer, and they'll be significantly closer with time to being swimmable and having swimmable streams everywhere, which is really the goal.
A waterway restoration plan is part of a strategy that promotes a sustainable, livable, economically vibrant, and healthy community for all of us to live in. Our planet is a single living organism with the land, water, and sun working together to provide a healthy environment for all of life. 71% of the world is covered by water, but only 2.5% of this water is fresh water. This small proportion of fresh water is what people use to drink, swim, catch fish in, and we use fresh water to raise livestock, vegetables, and fruit to eat. Without clean fresh water, we would not be here today. So this is a call for all of us to take part in cleaning up our waterways. Government officials can use this program as a starting point to discuss what should be done next. But the public can play an enormous role, first by learning more about the problems in their area, but most importantly, by contacting the people who are running the government and let them know how important this work is. If you want something done in government, the local residents have to speak up. I have seen this before. Local officials seem to not respond until their voters actually stand up and speak out. I'll close with a quote by Margaret Mead. Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it is the only thing that ever has.